Investigation of relative permittivity and microstructure of iron and silicon rubber composites. What is a magnetorheological composite? Magnetorheological composites belong to the class of smart materials that change their own properties under external conditions. They are similar to a magnetic field. Magnetorheological composite is a material consisting of a highly elastic polymer matrix and magnetic filler. Goal and tasks. The main goal was to synthesize the magnetorheological composites and investigate their properties. The main tasks were choose the optimal ratio of matrix and filler, choose the composite synthesis method, come up with the best research methods, process the results. Methods and materials. The synthesis method is an addition of carbonyl iron particles to a liquid silicon rubber, followed by polymerization in the form. The essence of the study is to obtain the dependence of relative permittivity on the magnetic field for obtained samples. For this, the composite in a liquid state was placed between two plastic cards covered with aluminum foil. By this method, composites with iron particles concentration were obtained 0, 40 and 17%. The capacitance was measured for each of them, and then the relative permittivity was calculated. The measurements were carried out using digital multimeter. The slide showed the microstructure of a sample with a mass fraction of particles of 40%. The gray background is the rubber, and the white dots are the carbonyl iron fragments. The left graph shows the dependence of relative permittivity of the composite on the mass fraction of particles of carbonyl iron. So we see that with an increase in the mass fraction of particles from 0 to 70%, the relative permittivity also increases from 3 to 100. The right graph shows the dependence of the relative permittivity of a sample with the mass fraction of particles of 70% on the presence of a magnetic field. It showed that when a magnet with a constant magnetic field is brought up to the sample, its relative permittivity increases by 8 relative units. Conclusion. So, main results. Magnetorheological composite samples were synthesized. The optimal ratio of rubber iron was selected. The microstructure of the composite was investigated. It was proved that a constant magnetic field increases relative permittivity of the composite. Thanks for your attention.